Hi all, I am Lakshmi Deepthi from Data Science Department. Today I am going to start the subject Data Handling and Visualization, which is the very important subject to the Data Science Department. And in that subject, I'll tell you what you are going to learn about that subject and what are the course outcomes and course objectives of that particular subject, and also one topic, that is data fundamentals. The course overview. This course introduces the fundamentals of data and its types, collection of data, preservation and organization techniques. The course also discusses data visualization techniques that are useful for preliminary analysis or exploration of the data. This course is an introductory data science course that lays the foundation for further data processing. It involves data modeling, analysis, and mining in all scientific and engineering domains. What are the course outcomes? The first course outcome is tabulate the data from CSV, XLS, text, and JSON files and export the table data to that particular files. Means we are going to export CSV, XLS, and text files and JSON files directly to our systems by writing some code. CO2. Course outcome 2. Make use of imputation techniques for wrangling the data for an authentic data analysis. Course outcome 3. Manipulate the tabular data using pivoting and cross-tabling to generate contingency tables. And course outcome 4. Manipulate the tabular data by joining multiple data tables. Course outcome 5. Explore the data using the data visualization techniques. Course outcome 6. Analyze the data for outliers to data, trimming the data required for authentic data analysis. This all the codes or what we are generating, the CSV files or XLS files or text files, we are going to write the code in Python. Means data handling and visualization using Python. Data fundamentals. The first topic is data fundamentals. Data fundamentals refers to the core principles and concepts necessary to understand, analyze, and work with data effectively. The key areas of data fundamentals are data types and data structures, data collection and sources, data storage and management, data processing and cleaning, data analysis and visualization, data science and machine learning basics. Data types and structures. Structured data organized in tables, rows, and columns with predefined schemas. Example, SQL databases. Unstructured data does not follow a specific format. Examples, images, videos, text files. Semi-structured data has some structure but not as rich as structured data. Example, JSON and XML files. The second one, what we are going to learn in these concepts or in this subject is data collection and sources. Primary data collected first hand. The primary data always means that we are collecting that particular data at a first time. Means the starting amount of data. Means example, we are going to collect that particular data from surveys and experiments. Secondary data obtained from existing sources. Already we are having that particular data. We are going to extract that data from examples, government reports, and also the data sets. In our subject, we are going to work in different type of data sets. The third one is APIs and web scraping. Automated methods to gather data. We are going to use some automated methods to gather particular data. Data processing and cleaning. Data pre-processing. Handling missing values, outliers, and duplicates. We are going to download or create one data set. We are going to search missing values in the data set and fill that missing values, and also duplicates means going to come more than one time. Means the data is presenting in that particular file 2 times. In that case, we are going to delete all the duplicates. The second one is normalization and standardization. Scaling data for consistency. Future engineering. Creating new features to improve model performance. Data analysis and visualization. Descriptive statistics. Mean, median, standard, and deviation. Data visualization. how we are going to visualize that particular data. MATLAB, Seaborn, Power BI and Tableau. Exploratory data analysis, EDA, understanding trends and patterns. Data storage and management. Always databases we are storing in SQL, structured query language. For that we are using MySQL and NoSQL. And data warehousing and lakes. Large scale storage selections. Example, Amazon Redshift, Google BigQuery. File formats what we are using here are CSV, JSON, Packbit and Avro. Data security and privacy. Data encryption and access analysis. Protecting our sensitive data. GDPR and compliance. Understanding legal aspects of data handling. Confidentiality. Ensuring only authorized users can access that particular data. Integrity, maintaining accuracy and reliability of data and preventing from unauthorized modifications. Availability, ensuring data is accessible when needed by authorized users. Data science and machine learning basics. Supervised learning. In that supervised learning, we are going to see about regression and classification. Unsupervised learning, clustering, dimensionality reduction, and modal evaluation. We can learn about accuracy, precision, and recall. Data handling. Now, I am going to justify my title of the subject. What is data handling and what is data visualization? Data handling means collecting the set of data and presenting it in a different format. Data is a collection of numerical figures that represents a particular kind of information. The collection of observations that are gathered initially is called raw data. Data can be in any form. It may be in words, numbers, measurements, descriptions or observations. Data handling is the process of ensuring the research data is gathered, archived or disposed in a protected and safe way during and after the completion of analysis process. Data visualization. The second part of the subject is, first part is data handling and second part is data visualization. Data visualization is a graphical representation of information and data. By using visual elements like charts, graphs and maps, data visualization tools provide an accessible way to see and understand trends, outliers and patterns in data. Additionally, it provides an excellent way for employees or business owners to present data to non-technical audience without confusion. In the world of big data, data visualization tools and technologies are essential to analyze massive amounts of information and make data-driven decisions. And data visualization is the graphical representation of information. Data visualization translates complex data sets into visual formats that are easier for the human brain to understand. These can include a variety of visual tools such as charts, graphs, maps, and dashboards. In charts, there are many types of charts: bar charts, line charts, and pie charts. In graphs, scatter plots, histograms, and etc. In maps, geographic maps, heat maps, etc. And in dashboards, interactive platforms that combine. Finally, we can say that in data handling and visualization, we are going to learn that how we are going to collect some data and handle that data, clear data cleaning and data manipulation. After that, we are going to apply some visualization techniques and convert that particular data, as we have downloaded one data set and we are doing all this process in that particular data. Finally, we are going to convert that data set into visualized graphs by using some visualization techniques. Now, the first topic of our subject is data fundamentals. What is data fundamentals? Data fundamentals in data handling refers to the core concepts and practices involved in collecting, storing, organizing, cleaning, and analyzing raw data to extract meaningful insights. These include key aspects like data types, data quality, data collection methods, data cleaning techniques, and basic statistical analysis to prepare data for further processing and interpretation. Data types. Qualitative data. We are having two types of data: qualitative data and quantitative data. Qualitative data refers to non-numerical information that describes characteristics, qualities, or categories. It captures rich descriptive insights into human behavior, social phenomena, or other abstract concepts that are difficult to quantify. Qualitative data is again we can represent them in two types, descriptive and categorical. The qualitative data is in the form of text and images. What is descriptive and what is categorical data? Descriptive data focuses on explaining what and why rather than how much. Example, describing the color of a flower as red instead of measuring its wavelength. We are describing the color of particular flower, but we are not measuring the length of the flower. That is the quality of that particular flower, but not the quantity. That is qualitative data. Categorical data. Divide into groups or categories without numerical ranking. Example, eye color, blue, brown, green, or occupation is teacher and doctor. It's the quality of that particular person. Eye color may be blue or brown or green, and the occupation of that particular person may be teacher or doctor. It depends on the quality of that person, but not the quantity. Subjective data, often based on perceptions, opinions, or interpretations. These are the three features of qualitative data: descriptive, categorical, and subjective data. Collection methods of qualitative data. What is the process of collecting this particular qualitative data? First of all, we are going to collect it from interviews, open-ended discussions to gather in-depth insights. For example, what motivates you to perform better at work? Focus groups, group discussions to explore opinions and experience. Observations, from different types of observations, watching and recording behavior in natural settings, and also from open-ended experiments, questions that allow participants to explain their thoughts in detail. From these four types, we are going to collect the qualitative data, and from the data, we are going to analyze the particular concept, what we want to do. When to use the qualitative data? You have learned what is qualitative data and what are the key features of qualitative and where we are collecting this qualitative data. After collecting this qualitative data, where you are going to use this qualitative data? When exploring new undefined areas of studies, when understanding subjective experience or perspectives, when studying behaviors or processes that cannot easily be quantified. These are the three places, example places. Not only here, we are using this qualitative data many places. These are the basic three examples where we are using qualitative data. When you are exploring new things and understanding subjective experience and also in studying behaviors. What are the examples of qualitative data? In business, the main thing in business is feedback, customer feedback. Example, the service was excellent. If the particular person who has been given you a service, if the service was excellent, it will improve your business. Otherwise, it will decrease your business because it is the quality of that particular person. And in education system, descriptions of students' learning experience. In healthcare system, patient experience with treatments or facilities. In social sciences, where cultural activities, traditions, attitudes are social norms. These are the four places, example places. Not only here, we can use many places. In business, education, healthcare, and social sciences, we are using this qualitative data. The second type of data, the first one is qualitative data, and the second type of data is quantitative data. Quantitative data is the data that can be measured and expressed in numerical terms, where in qualitative data, we are not measuring the data in numerical terms. We are just telling the quality of that particular flower, person, or whatever it may be. Here, we are measuring the quantity. Quantitative data is that which can be measured and expressed in numerical terms. It involves quantities and allows for mathematical calculations such as addition, subtraction, multiplication, and division. This type of data is used to quantify the characters of something and can be subjected to statistical analysis. By performing all this data or collecting this data, we can give the statistical analysis of the particular field or particular data. Suppose if you take students, in students, they are in classes, there are many students, example 70 students are there. In that less than 50 CGPA, there will be 10 people, and after 50 to 675 CGPA, 30 people, and more than 80 CGPA, they are 40. So averagely, at a time, if we want to analyze this particular class students, we are going to construct one graph. By seeing that graph, you can analyze the section's performance. Like this, we are going to represent the quantitative data. Quantitative data can be categorized into two types: discrete data and continuous data. Discrete data that consists of separate values, typically counted. Example, number of students, number of cars. Number of students, before I have explained you the example for number of students, and in the same way number of cars. Continuous data that can take any value within a given range, typically measured as weight, height and time. It can take any value within the given range. Means we are giving that range, means according to the capacity of that particular, example, classroom. We can only support 50 students in that particular classroom. So we are giving to that range 50 students, and they have to enter into that particular classroom in time, 11 o'clock or 10 o'clock, like that. In that time or in that only 50% in that particular time they have to enter into the class. In this way, we are going to analyze this quantitative data. Examples of quantitative data: age. A person's age in years. Example, 25, 30 and 40. This is a person's age. And height. A person's height in meters or feet we can measure. Temperature. The temperature in Celsius or Fahrenheit. These are all taking the numerical values, which is quantitative data. Income. The amount of money earned. How much money you are earning per month or per year, whatever it may be. Test scores. Scores for an exam. Exam 85%, 94%. These are all the examples. What are the 5 examples I have taken? Age, time, height, temperature, income, test scores, whatever it may be. These are all quantitative data. Based on the quantity present in that, we are going to measure this quantitative data. These are the examples for quantitative data. And the next topic is formats of data. Data formats. We are telling the data, we are representing data and qualitative data. What are the formats for this particular data? Data formats. Structured data, organized into rows and columns. Obviously, when we come for structured data, which is organized in rows and columns, we will go for SQL DBMS databases, SQL databases, and also Excel spreadsheets. Unstructured data. The unstructured data is always, the meaning says that not organized in a predefined format. Example, videos, social media, data formats, posts, etc. And when we come for semi-structured data, it is partially organized. Example, JSON or XML files. Data lifecycle. How we are going to collect, store, processing, and starting from collection to ending of that particular data. Collection. Gathering data from various sources. Example, surveys and sensors. Storage. Storing data securely in database or cloud systems. Processing. Cleaning, transforming, and organizing data for analysis. Analysis. Extracting insights using statistical or computational methods, and after analyzing the data, sharing the data, visualizing and reporting insights to stakeholders, archiving or disposal. From collection to disposal of data. Disposal means retaining or securely deleting data based on your policies. After the using the data, we are going to delete the data based on our policies. So, data life cycle from starting to ending. Next one is data quality. What is the quality of data? Data formats quality. Data quality in the context of data handling and visualization refers to degree. The quality in the sense means degree to which a data set is accurate, complete, consistent and reliable, ensuring that the information presented in visualization is trustworthy and useful for informed design making. Essentially, it means the data is good enough for the intended purpose. Data is free from errors and inconsistencies that could distort the insights drawn from visualizations. The quality finally means that the degree of that particular data and where you are using that data and how to complete and consistent data you are going to take, and is our intent what we are going to do that particular work, is the intent, our intent is good enough for that particular data, means our work and the data is matching or not. At the end, when we are going to handle and visualize the data, we are going to get the good results or not. This measures the quality of that particular data. And what are the 5 characteristics to measure the data quality? First one is accuracy. The data reflects the true values and is free from incorrect entries and miscalculations. Completeness. All necessary data points have minimal missing values. Consistency. Data is formatted uniformly throughout the dataset with consistent units and coding schemes. Timeliness. The data is correct and up to date, and the data is relevant or not. The data is appropriate for the intent, analysis and visualizations. These are the 5 characteristics you have to observe when you are collecting that particular data. If it match to your particular research or not, and at the end you are going to get results or not. This is the 5 characteristics of data quality. And tools and techniques what we are using: databases, SQL and NoSQL, and data analysis, visualization and big data. For visualization we are using Tableau, Power BI and MATLAB. Big data, Hadoop and Spark. And for analyzing the data we are using Pandas and NumPy in Python. Data management. How you are managing the data. Governance. Policies and standards for data usage. Security. Protecting data from unauthorized access or breaches. Integration. Combining data from multiple sources. Backup and recovery. Ensuring data is not lost. You're not going to lose any data. Means you're providing backup to that particular data. Ethics in data. Privacy, bias and transparency. Privacy means protecting sensitive user data. Bias, avoiding discrimination in data and algorithms. Transparency, clear communication about data use. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.